In this video, we're going to show you 3 ways to test your spark plug wires and find out if you need to replace them. It's super easy. Let's get to it. The most common symptoms of bad spark plug wires are engine misfires, a loss of power, rough idling, poor fuel economy, or a high-pitch radio noise. So if you have any of these issues, it might just be a bad spark plug wire. Luckily, it's super easy to test and fix. There's 3 ways to do it: a visual inspection, a spray bottle test, or a resistance test with a multimeter. Before you can inspect or test the spark plug wires, you need to know where to find them. They are these thick insulated wires that connect to the side of the engine block on the spark plug, one for each cylinder, and run to a distributor which looks like this. All the spark plug wires connect to it in a circle, and the center wire connects to the coil. However, if you have a V-shaped engine layout, you'll have spark plugs and wires on both sides, not just on one side like on our straight 4. To inspect or test the spark plug wires, you need to take them off, check, and reinstall them one at a time. That's because the location on the distributor decides the firing order, which is super important. If you take them off all at once and reinstall them wrong, your engine won't run. So only removing and reinstalling one at a time takes away the risk of messing up the firing order. What you then want to do is remove the wire from the wire loom if you have one and grab the spark plug wire by the boot. Never pull the cable itself. You'll rip it off the boot and destroy the spark plug wire. It's easier to damage than you'd expect. We found out the hard way in the past. You want to grab a firm hold of the boot, twist and turn a bit to loosen the seal, and then pull it straight off. Then do the same for the other end of the spark plug wire. If the boot is in a 90-degree angle, it's a lot easier because you can hook your finger under it to get a better grip when pulling the boot. And with the spark plug wire removed, you can inspect it. When inspecting the insulation, you want to look for cracking, cuts, burn marks, melted insulation, or even exposed wire. And don't forget to check for corrosion on the contacts. If you find any of these issues, it's best to replace your spark plug wires. For the spray bottle test, you only need a, you guessed it, spray bottle with the nozzle set to mist. What you then want to do is start the engine and spray the spark plug wires with water. The mist will make it easier to arc out against surrounding metal parts if there's a pinhole or damage to the insulation of the wires. It's best to turn off the lights or wait till it's dark. This way you'll see the arc a lot easier. If there is a short somewhere, even if it's a tiny pinhole you couldn't see during the visual inspection, you'll see it arcing in the dark. If there is anything arcing, you want to replace your spark plug wires. To perform a resistance test of a spark plug wire, all you need is a simple multimeter with a resistance setting, which is indicated by the horseshoe symbol. Our multimeter only has one resistance mode because it automatically detects the range needed. But if you have multiple resistance ranges, you need to select the 20 kilo ohms one. So 20k ohms. Initially, your multimeter might display OL like in our case, which just stands for open loop because the probes are not touching anything. But once you close that loop, you'll get a measurement. It's also possible that your multimeter displays a 1. That's because the resistance is too high to measure in the selected setting, or you haven't started measuring yet. Then first look at the resistance of your test cables. This should be almost none. We're measuring thousands of ohms, so a difference of a couple of ohms doesn't matter at all. What you then want to do is connect the test probes to both ends of the spark plug wire, and make sure you have a good connection. The resistance is measured in ohms per foot of wire and varies depending on the type and brand of spark plug wire. But for most regular wires, you should get about 5,000 to 8,000 ohms of resistance. This one is about a foot long and gives 10.5 kilo ohms of resistance, which actually is not too bad. However, what you then need to test is whether the resistance stays the same when bending the spark plug wire, because in some cases the internal wire is damaged or broken and it only gives contact in certain conditions. And you don't want a spark plug wire that occasionally causes a mystery engine misfire. And as you can see, depending on how we bend the wire, the multimeter indicates an open loop, meaning that the wire inside is broken. So although it might pass a visual inspection and water spray test, this way you can still find a bad wire. The red one is from a bad set of spark plug wires we replaced a while ago, and the black ones are new. When comparing just the resistance, you wouldn't notice a 500 ohm difference while driving, but the broken internal wire was the real issue. But even if you perform all these tests, you can never be 100% certain the spark plug wire isn't faulty. The issue might only show up on high RPMs or when the wire is hot. So if you have any doubt or want to rule out that possibility, it's best to replace them, especially if they're old. When installing new spark plug wires or reinstalling the old ones, you need to make sure they click into place. It's not enough to push the clip against the contact. The spring-loaded clip should make an audible click when pushing it over the contact, like so. Then do the same for the other end. Once again, you want to hear a clear click. Then when all the wires are checked and replaced if necessary, put them back in the wire looms and make sure they are nicely secured and not rubbing against the exhaust manifold, which can melt them. If you don't have wire looms, we'll show you how to make those yourself in a separate video. That's all there is to it. Now you know how to test spark plug wires. Thanks for watching. More videos are on the way, so be sure to like, comment, and share this video. It really helps us out a lot. Our content wouldn't be possible without the amazing support of our patrons and YouTube channel members, whose crew you can join via the links in the description to see our schedule, vote on future videos, get behind-the-scenes sneak peeks, and much more. This is Classic Car Maintenance, and we'll see you on the next one.